Factoring using difference of squares. Let me show you a trick. If we have x squared minus 4, we could take the square root of x squared and we would see that that is x. And if we took the square root of 4, we would see that that is 2. So these two terms are perfect squares. And then we take the minus symbol. This means the difference of. So that is where this learning goal comes from. We are taking the difference of two squares. So once we know that this is a perfect square and that this is a perfect square and have a negative symbol, then we can do this. So we have the square root of x squared is x plus 2 and x minus 2. Why? Well, we do this because the square root of x squared is x and the square root of 4 is 2. And then all you have to do is put the plus symbol and the minus symbol. Okay, so here again we have two perfect squares. And we're not talking about the squares that look like this. We're talking about the squares that can be two numbers that you could take the square roots of. Always look to see if you have two perfect squares, two numbers that you can find the square root of. Then you look for the minus symbol. If this was a plus, it would not work for the difference of squares. So once we know that 81 has a square root and 9 has a square root, we know that we're going to have two binomials. One is going to have a plus and one is going to have a minus. Now all we have to do is figure out what numbers are going to go in these binomials. So we are going to find the square root of 81x squared. And we know that that is 9x. Then we're going to find the square root of 9. And we know that that is 3. We are not going to find the square root of negative 9 because these are going to be what's in the binomials. So now all we have to do is write these in, and our problem is solved. Okay, so this is going to be our last example, and it's going to be a little bit trickier. So make sure you pay attention to all the simple things that we will be doing. So first of all, we are still going to look to see if we have two perfect squares. But we are going to leave this part out and just worry about what's in the bracket and drag this down when our answer is complete. So let's look and see if 4 has a square root. It does. It has a square root of 2. So that means that this is okay because 4 also has a square root of 2, and we know the square root of 1 is 1. Therefore, we have two perfect squares. So the only thing we have to look at now is if there is a minus symbol or a plus symbol. In this question, it's a minus symbol, so we can use our difference of squares process. So let's start. We know we are going to drag the 4a squared down to our answer. And then again, we will also still have two binomials. One with a plus and one with a minus. Does this look familiar from our last examples? It does. So let's see. The square root of 4 is 2. And we still are going to have the a. And the square root of this 4 is also 2. So we are going to have 2a squared as the square root of 4a to the power 4. Now, the square root of 1 is 1, so we just bring down 1. And the same is going to go in the other bracket to finish off our answer. Wasn't so hard, was it? Hope this video was helpful.